So it's a real pleasure for me to provide this introduction for our final keynote speaker of today's 2023 conference, Sigrid Brell-Cokcan, who's coming to us online to finish off the day. And Sigrid is someone, she and her partner from Robots in Architecture, Johannes Braumann, actually first met 12 years ago in Calgary at a Acadia conference, and was really blown away by what they were doing by opening up the field of robotics to groups of architects who clearly are not automation engineers or computer scientists, but taking a very difficult tool to use and enabling its use. And that's something that I was really energized by earlier on in my career, and subsequently invited them down to run a workshop at Bonn University where I used to teach. And so, it's fantastic to have another opportunity to overlap with Sigrid today, and also building upon, and some of you may have been involved in the 2016 iteration of the Robotics in Architecture Conference that was held in Sydney, and may know her from there. So for those of you who don't know, Sigrid Brell-Cokcan is the founder and director of the new Chair of Individualized Production at RWTH Aachen University. And she also co-founded, as I mentioned, the Association for Robots in Architecture in 2010, together with Johannes Braumann. In 2003, Sigrid was the founding partner of two architects in Istanbul and Vienna, with Baris Cokcan. Prior to this, she worked with renowned international architects and engineers Coop Himmelblau, Frank Gehry, Peter Cook, and Bollinger Grohmann on projects such as the Kunsthaus Graz, the MARTA Herford, and also BMW World Munich. She holds a doctorate in technical sciences from the TU Vienna from 2014, a master in architecture from 1998 from the Academy of Fine Arts in Vienna, where she was also honored with the Carl Appel Prize. She's a member of the Austrian Chamber of Architects and has completed international studies in architecture at the University of Sydney back in 1994. So, in terms of the two components of Sigrid's sort of professional life and what she's going to talk to us a bit about today, firstly, Robots in Architecture is really the leading international research and software development entity, making industrial robots accessible for the creative industry, not only in architecture but also in the arts, and particularly for inexperienced users. And in particular, the KUKA PRC plugin for Grasshopper, which some of you may have experimented with, has really, as I said before, has democratized and accelerated the uptake of designers' ability to visually code robotic controls. So in Sigrid's role as chair of Individualized Production, she employs researchers from different fields of robotics and building production to streamline the necessary digital workflow from the initial design to the production process. This focuses on the innovation of material and machinery to enable efficient man-machine interaction in building production, and is shaping the construction site of the future on the reference construction site in Aachen that she'll be telling us about via intuitive and easy-to-use interfaces. So with that, please join me in welcoming Sigrid Brell-Cokcan.
Hi, everybody. Well, thank you, Chris, for introducing me. And yeah, I'm very honored to be a little bit back in Australia. I mean, not personally, but at least online. So today I'm going to talk about two things that you have been mentioning before. One is collaboration, and the other one is also, that has been the topic of the whole conference series, is about how to build platforms and networks. And so robotics and AI for sustainable construction is more or less one of the key changes probably in the next 10 years. So somebody has to change. So the idea about to mechanize or automate the construction work itself, it's not a very early, it's not a new idea. It has been already a vision of the artist Vilmar at the beginning of the Industrial Revolution. So what you see here in this early on drawing from 1910 is the architect as a future vision for the year 2000 to actually control the construction site and still be in the control of the construction site. And this is also something which is quite important for us in education. Another topic, obviously, is also the UN sustainability goals, where you can also see that especially the goal 5, 11, 12, and 13 out of the 17 goals are the goals that we have to look at very closely in construction. So one has to do with gender equality, which means that especially on construction sites, people above the age of 50 are most of the times excluded. The same with women. So we only have 1% of women who work on the construction site. And this was a very similar situation that we had in 2006 when we got to know robotics, is that the actually control panel of robots were so big that a woman's hand could not even hold it. And so these are all things that we have to think about. Also, obviously, the building sector is responsible for 33% of global waste and 40% of total energy-related emissions in construction. And obviously, also the whole built environment exceeds actually our natural environment, like shrubs and trees. So the idea was, as Chris mentioned, to set up a network and a platform. And we were really happy to be able to support a couple of universities like Sydney University's RMIT and Bond, where Chris was then at the time professor, to host the first ROBARC conference in Sydney. And we had a fantastic time, a totally mind-blowing conference topic where people could work collaboratively and get exposed to actually work with robots. And one of the key things that I keep telling industry all the time is that we also have to think about our future work for the future generation. So a lot of people are interested in robotics in an early age, and the decision makers, they are not exposed to robotics at all at the moment. So at the moment we have the transition of society from becoming a totally digital society where still the decision makers are from the non-digital part of the world. And I think this transition is something we really have to support, and also how to make our work accessible, but also fun for the digital youth, and robots can play an important role with that. So Robots in Architecture is also a digital platform. As Chris mentioned, we have provided Cooker PSC as rather a quite open platform. And then obviously also the heat map shows, can we go back? The heat map shows that we do have a quite vast community, and we can see that we have more than 1.5 million launched Cooker PSC in the last 3 years by just counting the online users. And our community is also part of more than 100 universities. And so we are really thrilled, and you can also see the red dots in Australia, that when we came in 2016 and there were nearly no use in robots, so the use is constantly extending. And we are really happy that we have not been able to meet in person for the last, since 2018, so the last conference was in ATH. So the next conference will be in Toronto. So we are traveling the world more or less. And we are also happy that in Toronto, also 3 universities teamed together to host this university. So the workshops will be in May 21 and 23, and then the conference is following on May 24 and 25. And it will be, again, exceptional, where actually the creative industry from film industry, design and architecture will meet together with academia and also industry members. Coming back to KUKA PSC, what we also see is through the accessibility of robot programming out of our environment. I mean, Rhino is a cat environment, and Grasshopper is more or less, a plugin for visual programming. That means that we know that more than 30,000 students enter the construction industry after their diploma or master in architecture and civil engineering. And so a lot of from our association related education enters a lot of businesses, really going beyond the usual architectural firm. And so this is, I think, one of the keys that will change construction and the market in quite recent years. And obviously, we would like to meet constantly again every second year. So I'm just flicking through a couple of our members. You see they are all in the construction industry branch, technology. We have it also in arts. And a lot of 3D printing companies who are using robots are also using KUKA PSC. And we do have actually also big buildings, like if you go to Germany, one of the biggest railway stations, the scaffolding is done by a robot. We see that new markets and new ideas and new startups have started in the last years. Just instead of putting a car in the garage, they just start with putting robots in the garage. And this will be hopefully one of the reasons where we can contribute really to the sustainability development goals from the UN in the near future. From my personal perspective, I think apart from modular prefabrication that we have been seeing, which is very close to the car manufacturing, I think on construction site, the first robots will quite soon be installed in demolition. And one of our projects, we have been looking, especially in Europe, we have a lot of existing building stock, and to meet the sustainability goals, we have the 3 R's, which means reduce, recycle, and just reuse it again. And so we look a lot into how can we actually deconstruct in a controlled way existing building stock so that the material can be used. And this is a project close to the Dutch border, where we actually cut a whole building into big chunks. And the idea was to create family houses out of that.
Construction is one of the most critical economic sectors for current climate change, accounting for over 39% of global CO2 emissions. Current construction contains over 28 billion tons of concrete. This is 42% of the global building material supply. Cement, which is the basic material of concrete, makes up 8% of global CO2 emissions. 28 billion tons of concrete represents a significant source of secondary building parts for reuse. An interdisciplinary team at the Chair of Individualized Production at RWTH Aachen University is developing new methods for material harvesting by increasing the levels of automation in the deconstruction process. The Roboton research project bridges this technological gap by transforming an existing manual demolition machine into an automated deconstruction robot. The hardware of the existing Brock deconstruction machine is extended by attaching motion sensors for each axis. The deconstruction robot is supported by a second mobile robot for environment detection and component recognition. A digital twin is connected to the robot control through a newly developed user interface. The Roboton project researches into precise movements of the automated Brock joints in Hilti saw. The movements are virtually pre-planned, then adapted to construction site requirements. Concrete is a new source of secondary building material. The aim is to increase the lifetime of existing concrete construction. The Roboton Research Project enables automated deconstruction and the creation of new building processes for modular reuse of harvested concrete building parts. The future goals of the Roboton Research Project increase the controlled deconstruction by 40%, increase worker safety through automation, reuse 70% of existing concrete building construction for the extraction of secondary building parts, reduce global cement-based CO2 emissions by 1%.
So what you saw here is more or less that we, in our research in Aachen, now go beyond the industrial robots. So our next goal is how to robotize construction machinery. Obviously, there is some interesting development to be done now, is how to navigate on construction sites. And so what was important now is that we realized that only a digital programming software is not enough to really research into the future of construction. So we actually set up this new construction site that was actually supported and sponsored by our industry partners when we set up the new Center for Construction Robotics. And the idea in the background is, or what we also realized is that, I mean, we have great planning tools, we have great digital data platforms, we have great robotics, but when we send information on the construction site, it is prohibited due to the fact that data just does not reach the machines or does not reach an iPad or a server and things like this. So that's why we set up a project which was called Internet of Construction with 10 partners, where we actually built on our reference construction site and wanted to see that, I mean, how is information and transparency and where are the missing links coming from maybe pre-production or the information coming from planning data to the construction site. And in this project, we also analyzed a lot of the data platforms that actually our architects and civil engineers are working on, especially IFC data models and BIM models. And when you compare this, for instance, to automation ML, you see immediately that, you know, the whole hierarchies and structures in IFC files are quite complicated. And automation ML is quite interesting because you can actually also organize data without actually having a standard. Whereas in BIM, we always need to have a standard first, and then we can produce data. And so our technologies that we are looking in very, very constantly now is, for instance, artificial intelligence and ontology. So that's actually also a technology that is existing for a long time, since the 60s in linked data. And here the great part is that it is actually possible to orchestrate construction along the value chain independent to the level of digitalization. And you can decompose software that we are using in construction. And in this project of the Internet construction, we actually had to work with 24 softwares and with people. So also people can take a role in the orchestration of information. And so one of the projects is actually also data capturing. We also need a little bit of sound here, but I'm talking to that now. And here it is quite interesting with the side of physical systems and how to actually set up communication networks. And then obviously also how to integrate the normal use of material and information in the construction industry and how to feed this back into a BIM model with the use of technologies. Yeah, so we can just click here through. So automated resource allocation is one topic. Then obviously also creating a crane to be a logistic, similar like in Amazon. that the crane can tell you where to locate what building part and what process. So also enabling cranes to be roboticized. And then obviously also having the cost and all the prediction of what is happening in the background, economic analysis. So in the end, I can show you what was the output. So we had a little demonstrator coming from wood, steel, and concrete, where we actually had a live feedback in our BIM model. We looked into the automation of all the data coming from pre-production to the construction site, also by the use of AR technologies for the construction workers to understand what's going on. And then incorporating the as-built data into the BIM model just at the time when it was built in real life. And we realized that 44,000 questions were asked to our BIM model, which means that the next generation will be in how to orchestrate this information with other technologies than what are available, like Wi-Fi or whatever. So we are deeply looking now into 5G and how the future of 6G should look like. And just to, we are now part of this 5G industry campus Europe in Aachen. So we moved the construction site to a new space where we now can also perform in the 5G network our performances and our processes. So we look into how robots actually work together with elevators or with cranes.
We're taking ideas from different industries and integrating them into one process that could add more intelligent automation to construction sites.
So our main projects at the moment are now working with 5G and with edge computing. So we are trying to set up a whole networked system on a real construction site, because we just realized that digital platforms are good, but if they can't meet the construction site and serve workers on the construction sites, we still have a problem. And at the moment, about maybe 10% of data are coming and reaching the construction site. So they're still working with plans and whatever. So that is the goal that we would like to pursue in the next years. So thank you for your attention. And if you need any further information about the reference construction site and how we set this up, then please also feel free to contact me. Thanks so much. And I finished, actually.
Yeah. Thank you very much, Sigrid. That was wonderful and very inspiring, and I think a great way to conclude today's set of keynotes with a body of research that is obviously very comprehensive and world leading. So thank you very much, and thank you for getting up very early. I can imagine it's the crack of dawn there. So we appreciate you making the time and the effort.